Hi, my name is Annika and I'm currently an AP Chem student, and today I'm going to be doing a brief overview slash introduction to ICEE tables, which are also known as rice tables, but I'll be calling them ICEE tables. So let's get started. The first thing you need to know is how to write Kb and Ka expressions. A quick review. Kb is the K expression, the K constant for bases, while Ka is for acids, hence the B and the A. Writing them, you have to start with the dissociation equation for the respective acid or base, and then products of reactants. Pretty basic, you should know how to do it. It's just a quick review. Some examples, we have nitric acid. Nitric acid's dissociation equation is HNO3 yields the H plus ion plus the nitrate ion, and the Ka expression is Ka equals the concentration of the H plus ion times the concentration of the nitrate ion all over the concentration of nitric acid. So, calcium hydroxide, a base. Calcium hydroxide solid, keep that in mind, yields the Ca2 plus ion plus 2 hydroxide ions. Also pay attention to the 2 there. The Kb expression is Kb equals the concentration of calcium, the 2 plus ion, times the concentration of hydroxide, with the 2 exponent because of the coefficient on hydroxide in the equation. And also notice that there is no calcium hydroxide in the K expression. It's a solid, it's not going to be there. So, ICEE tables, let's talk about them. They are used in equilibrium problems, often when you are dealing with initial and final concentrations. You usually use them when you are given one equilibrium concentration unknown, but there's at least 2 other unknowns in the problem. They're very, very useful. You will notice there are tons and tons of problems you can use them for, but try not to overuse them, because sometimes there are ways to solve a problem easier, or you have to use a different thing that may be a little bit harder to solve them. ICEE tables won't give you the actual answer you need, so try not to overuse them. So the acronym, I is initial, C is change, E is equilibrium equation, and E is equilibrium. And pay attention, things to pay attention to. The molar ratio of things in your equation, reactants and products, that is also going to affect your variables. There's going to be X in your table, your ICEE table. Just in general, your basic algebra, pay attention to the molar ratios. Just the strengths of acids and bases. This will affect assuming when something goes to completion or if something barely dissolves at all. So, an example problem. I'm going to talk through this one, explain it, and then I will give an example problem, and you can try that, and I will provide the answers. So, acetic acid has a Ka value of 1.8 times 10 to the negative 5th at 25 degrees Celsius. What is the concentration of the H plus ion at equilibrium if the concentration of acetic acid at equilibrium is 6.0 molars? So, let's unpack this. First, write your table. Do the ICEE acronym down the side. I just wrote it out because it helps you visualize it more. And on the very top, write out the dissociation equation. So there's going to be 3 columns down. And then you fill it in. For the initial, I don't know what the initial concentration of acetic acid is. They don't give it to me. So I put a question mark. And knowing that we only start with acetic acid, I put the initial concentration for the products at 0. So now the change. We know we're using up acetic acid, so I put a negative X. And then it's producing those 2 ions, so plus X for both of them. The equation, a lot of people tend to merge the C and the first E steps together. That is completely up to you, but personally I like to separate them. So you just combine the first 2 columns together. So question mark minus X, 0 plus X, and 0 plus X for the equation. That will produce your equilibrium concentrations. So at the very bottom, for acetic acid, they give us what the final concentration at equilibrium is, which is 6.0 molar. But I don't know what the final concentrations at equilibrium are for the products. So that's what X is. So solving that, using that data, I wrote my Ka expression first. Kb, whatever the instance is, write your K expression right away. So the products over the reactants, basic, we got that down. plug what you know in. So we know that the K value is 1.8 times 10 to the negative 5th. Easy, plug that in. We know that the final concentration of acetic acid is 6.0 and that the final for both of the reactants is X. So I plugged that in. Now it's just basic algebra. I solved that and I got that the concentration of H plus is 0.010 molar at equilibrium. If it was asking me what the concentration of the other ion was at equilibrium, it'd be the same thing due to the molar ratio. So, mathematically, let's break that down. Use your algebra skills. It's just knowing how to do basic rearranging of things to find X. You should all have gone through algebra at this point. You know how to do that. The quadratic formula is sometimes used. In our practice in Mr. Krowski's AP Chem class, he will have us use that sometimes. It's good practice, but know that this is not going to be on the AP exam at all. You will never be asked to use this on the AP exam. The quadratic formula, that is. Assuming the reaction goes to completion. This depends on the strength of the acid, the base, and or the Ka, Kb value, if it's given. If it's a very high K value, close to 1, it's going to effectively go to completion because it is products favored. Vice versa, it's going to go to reactants if it's not anywhere near 1. Keep that in mind, but you should know that by now. And also, if it's a very, very strong acid or base, which you should know because that is required for the course, it will essentially go to completion. So, this is the problem that I'm going to give you. Go ahead and try to solve it and pause the video and come back. So I hope that that problem went okay. It's okay if you went back in the video and tried to figure out the steps along the way, but let's break this down. Let's establish what's happening. You have 0.26 moles of a weak Arrhenius base that is placed in 750.0 milliliters of water. After equilibrium is reached, the concentration of the hydroxide ion is 0.094 molar. What is the Kb value? So my hint was to write the equation. So I have XOH yields the X plus ion plus hydroxide ion. Set up my ICEE table. We know that the initial concentration is 0.35. I just did basic, moles over liters, converted some things. That's where I got that from. The initial concentrations of the products is 0. I did my changes because there's no difference in molar ratios in this problem. The only thing that's different now, we don't have the K value, but we do have what the final concentrations are for the products. So I wrote that down. And I know that the equation is 0.35 minus X for XOH. So I just did some basic algebra, subtracted some things, and I got that 0.26 is the final concentration of XOH. Pause the video if you need to break that down even more, but it's just some simple algebra steps to get there. So now I wrote the Kb expression, which is Kb equals the concentration of the X plus ion over the concentration of hydroxide ion all over the concentration of XOH. I plugged those values in for the concentrations that I knew. I just did some basic algebra then, and I got that the Kb value is 3.4 times 10 to the negative second. So that is it for this quick intro kind of overview of ICEE tables. They kind of get a little more complex, but just keep in mind basic algebra skills. Just rely on that. So thanks for watching.